I know that this is supposed to be an introduction for the 10th seminar, and Nawal, she mentioned that I'm going to be giving a talk, so I decided that I will give a talk today. So I think in addition to talk about the seminar itself, I will give a seminar. So first, I wanted to thank Denisa and Lama and Javier for being the coordinator for this seminar. And I will talk a little bit about the Transportation Kent seminar first. So let me see if this is going to work. So here we go. All right. So this Kent seminar will be from 2 to 3 p.m. every Thursday, and we'll have it here in this place, but also it's going to be available on Zoom. And it will start today and it will end on December 9th. This is here the webpage for the seminar, and people, they can join the Zoom at any time. Most importantly is to talk about the person behind this. Paul Kent is an alumnus of our civil engineering department in 1920. With his generous gift, we were able to have this series of Kent lecture for the past 13 years. We were able to invite people from across the country and from overseas and give also distinguished lecture. This person, he worked on several civil jobs in the state of Illinois and surrounding. He was also a contractor, and he has his own, or he had his own business in contracting. He was the founder of the Civil Engineering Alumni Association, which is now the largest in civil engineering in the country. So we owe it to him for doing this. And he received the University of Illinois Loyalty Award and Civil Engineering Distinguished Alumnus Award. So we are very thankful for his gift that it's now allowing us to do this seminar, bring you the pizza guys and all that stuff. So we thank, of course, his family for doing this. This year, as always, we're trying to bring some distinguished speakers in order to talk to you, as well as we try to encourage our PhD students to be part of this program. So this is here a list of the speakers, and I will go through what we're going to be doing each month. So in September, we have Bill Spencer going to be talking about computer vision and the inspection and the health monitoring. And we have Gia Wu going to be talking about the aggregate imaging. We have Lee Zhu from Virginia Tech going to be talking about autonomous vehicle. And John Anderson, he's one of our alumnus who has a very successful career in contracting in Florida. He will be talking about how he developed his business into a successful enterprise. And then we're going to have Puneet talking about the softening asphalt binders. Of course, these are not exact titles. This is just to give you an idea about the topic that we'll be talking about. In October, we will have visitors from FHWA, David Menching, as well as Amir Golabor. He is both going to be talking about resiliency. This is an important area at the FHWA at this time. Ali Riza is one of our faculty here. He has been working quite a bit on project going on. So it will be great to have him talk about interconnected mobility. And Nadia, she will be visiting us from Purdue, talking about sustainable transportation. Actually, when I was there, Virginia Tech, she graduated from there. She was a student there. And Cara from University of Texas at Austin will be talking about electric vehicle and electrification mobility. So these are some important topics that will expose you to all various aspects of pavement systems and pavement transportation in general. Julie is an outstanding researcher in rigid pavements. She will be visiting us from University of Pittsburgh. And Samer Dasuki was one of our postdoc here, actually years back. He is now a professor at the University of Texas at San Antonio. We'll be talking about flexible pavement bases. He has been doing a great job over there. We're working on a distinguished lecture that to be announced, I guess, soon. Now, before I go to what are we going to do in December, I thought I will give you a little background about the discussion for the December lectures. So many of you heard about the I Act, or the Illinois Autonomous and Connected Vehicle. So for the new students, I will just give you a little background here. This is a vision that we have for the past 2 years, and now it's taking some, I would say, significant steps to move forward. The idea behind this is, if I can use this one here. So the idea behind this is to have 2.4 miles that will allow trucks to travel continuously at 75 miles, up to 75 miles an hour. This is an area where we're going to be doing agricultural research. This is an area for dynamic testing, and this is an area where we have multimodal transportation. This is an area for doing different environmental conditions during the testing, and there is an area here for urban and suburban testing areas. So in general, you're going to find that we have planned for a very complex, but at the same time, I would say state-of-the-art facility that will allow us to test the different development and innovation in the autonomous and connected vehicles, and we're going to be focusing more on the trucks or the freights in general. There is some work going on as we speak, some projects working on the development of 5G for this I Act, energy harvesting, as well as electrification. We're working now with NCSA to see how we're going to be storing the data, and having an interface with the data as it's collected. So there's a lot of work going on, and the reason why I'm mentioning this here, because that's going to be impacting what I'm going to be talking about here in December. There is an economic study that we have finished recently by an expert, in which he's expecting that there will be $3.5 billion in total impact between 2021 and 2050, and that will generate close to $500 million in taxes, and also 23,000 jobs in the state of Illinois. Where we are right now on this, actually, we have done some preliminary environmental assessment by a company in Springfield. The Village of Rantoul provided us with 238 acres. We're going to be needing around, I'm not sure yet, it's going to be anywhere between 420 to 500 acres. That's why we hired a company by the name of ACOM, which maybe many of you are familiar with, and they are doing the conceptual plan for us, and they already got that work. So part of their work is to come up with several alternatives, at least minimum 2 alternatives, but could be 2 to 3 alternatives, to give us the best options for the design of this vision. So to share with you also how this looked like in 1-minute video, and I will explain this as we go. This is here where we are. You can see this is close to the airport, close to the interstate highway, close to the railroad. That's how you come every day. The people who are here, campus. This is the outside circle, if I may say. This is here testing freight. You can see the inner circle here inside, the ones that I just showed you in the schematics that we have. And as you are driving here, that's the people who are here, I guess. That's where you are right now in this building. And this is a new building here where it's going to be the control center. And this is the suburb area for the various testing. And this is the all environmental or all weather conditions. And this is the dynamic testing pad. And this is the multimodal facility. And this is an area for testing agriculture machines and so on. So overall, I think it's, when we did this, we looked at many different tracks available in the United States and abroad. And we definitely gonna have this completely distinguished. So the reason why I mentioned this here, because I know some of you keep asking about this, I thought that I would give you this idea here, because one of the things that we did, is we wanted to be ahead of the game and ahead of the conceptual plan. So we are doing some research already on this. So we got some funding from the university. It's called the growth funding. And part of this growth funding, we came up with 24 projects. Every year we are giving away 8 projects for people to do research. So right now we have 8 projects that they are out and people are doing research that it is relevant and related to the IAC. So what we're going to do is to try to present 4 or invite 4 of the people who are doing these small projects to talk about what they are doing in this semester and 4 in the next semester. So Angeli, she will be bringing 2 of the speakers, Ramiz and Jason, and Naira and Chinlong. So we're going to have 2 panel discussions regarding to the IAC. And at that time, I guess they will talk about what are the things that they are doing or innovative work that it's being done as related to this project. So with that, I wanted also to ask many people who are working usually in putting this seminar together. This is run by students, and I'm here just for the first time just to welcome you all. But it's run or coordinated by the 3 students that I mentioned earlier, and it's supported by several people in the staff. I want to thank Noel, Angeli, Emily, Christy, John, and Egeman for their help to keep this going. So I'll stop here for 1 minute and see if anybody has any question about IAC, because I thought, as Noel put me on the spot here, I should be talking about something technical too. So I thought today that maybe it's good to talk about freight and talk about something that is related to both the systems as well as the pavement. So I'll stop here for a minute and see if anybody has any question about the Kent seminar or IAC. Any questions? Is that good or bad? It's good? All right, and we'll keep going. All right, so I thought that it's maybe a good thing to talk about the platooning, because several of our students and faculty, they are working on the logistics of the freight, and several are working on things related to pavements. And this is something that I can connect both. So what I will be talking about today is 3 things. First, the concept of platooning. Second is what is the impact of platoons. And third, how we can use this challenge as a learning opportunity for us, where something that it's supposed to be damaging the pavements, how we can make it improving the service life of the pavement. So before I go, I think I wanted just to present to you, just to have a snap picture into 2050. So if we look at the number of the population, that's going to be increased by 26%. We're getting closer to the 10 billion. The number or the percent of people who are going to be using airplanes is going to be increased dramatically. Actually, in Chicago, that number is going to be increased in the range of 300%. So in the whole US, it's going to be increasing by 500%. Then more people are using the e-commerce, and the weight of the freight will be increased by that time by 300%. And one thing that it's interesting, I noticed myself is when I read a couple of articles 2 years ago about people that they don't like to do a lot of trucking work. And you're going to see here, I'm talking about the shortage of the truckers because of the health issue and the back pain. And I never connected these things together, but there is 2 refereed article about this topic, which I found really interesting. Congestion is going to be increased because the vehicle kilometer travel is going to be around 120 T, and that will increase also the delay and the congestions to around 4 hours per week. More people are living in the urban area at the expense of the rural areas. So the rural areas will be decreasing by 39%, while you're going to be seeing almost the 2/3 of the population living in the urban area. So all this together means one thing, that there will be more demand on the infrastructure and the capacity is less. So something needs to be done. So I'm going to be focusing about what can be done from the trucking point. Before we get this, if we're going to be getting into the autonomy as well as the connectivity, there's few things that we need to pay attention to. The first is the safety. So we definitely, any new technology, it must reduce the number of fatality that we have. Second is we definitely wanted to minimize the congestion. Actually, if you look at the reports coming from FHWA, it depends on the year you look at it. One year you will find that safety is the biggest issue, another year you'll find that congestion is the biggest issue. So these two items are really big on the agenda of the federal government in general, or the transportation community in general. This topic is where I'm going to be talking a little bit about, which is how we're going to be optimizing the freight, because that's going to have a direct impact on the economy. And of course, everything has to be transformative into the benefits of the society. So everything has to be connected to the society as we move forward. Now, I'm going to be talking a little bit about the optimization of the freight. Before I get into this, we need to realize here that trucking industry is, in 2019, they hold around almost 12 billion tons, which is around 72% or 72.5% of the US freight. And this is at the cost of close to 800 billion. And if you look at the revenue, according to the American Trucking Association, it's around 80.4% of the whole transportation revenue. They're expecting this number to increase between now and 2026 at 4.5%, and then stable at 3.5% to reach to 18.8 billion tons. So that's really significant. So that's where the idea of trying here to do the truck platooning. Let me just go back a little bit here. Oops. Yeah. So before I go forward here, I want to just make sure that we all understand the term platoons, what it means. Platoons means that you have the trucks traveling behind each other at a shorter distance than the regular traffic. Usually trucks have around maybe 200, 250 feet between them. This year will be shrinking this distance to maybe 50, 60 feet. Some people are proposing up to 10. Of course, I'm not seeing this in the next maybe 10 years, but at least we are shrinking this distance. There's many companies who are already starting working on this, from Volvo to Auto, Uber, and so on. And this is supposed to do a few things. One is they are proposing this as safer. It is going to be saving a lot of fuel, and saving 5 to 15% of the fuel. It's a lot of money for the trucking industry. Literally, most of the money that is spent in the trucking industry is fuel and labor. That's where most of the money. Okay, so this is big. Now, one thing I wanted to clarify today. It's true that we're talking about trucking autonomy and connectivity, but the truth is the trucking industry now, it's moving more into the connectivity and have connection and less on the autonomy. So the investments, you're going to find it that it's more on the connection, all right, rather than on the autonomy. Okay. So whatever I'm going to be talking about here is I will be talking about connected vehicles. So let's see what are the current issues that's going to require, like why we should be talking about platoons. First, there is a driver shortage. In 2020, it was estimated at 61,000. By 2025, this number is going to be increased to 90,000. Although they are, quote unquote, that's what it is, believe that it's a well-paid job, but of course there's many advantages and disadvantages for it. So I will not be discussing this, but there is a shortage in the drivers. Second, the drivers' conditions, like 55% of the drivers are older than 45 years old or more than 5 years old. People cannot work more than 11 hours. It's like the pilots, they have a number of hours that they can work, and they cannot work more than 60 hours per week. So there is a limit to how much they can work. So this means here that you cannot have overtime to compensate for the shortage. That's what I wanted to say. Then you have the safety. Usually when a truck has an accident, the cost is very significant. So usually it's average around like 7.2 million per accident. And in 2015, there's more than 4,300 of these accidents. So you can imagine the number. And most of the time, this is related to human error. And congestion, it is believed that if you're going to be having platoons, the congestion is going to be reduced dramatically. Depends on the literature that you're reading. This can be as low as 2% and as high as 25%. And finally, which is the most important thing for the trucking industry, is the fuel consumption. So the trucks are believed to be reducing the fuel by 5 to 15%, and we're going to be seeing this here in a minute. So where this fuel reduction is going to come from? For trucks, there's 3 areas where the fuel goes. First is the engine, the machine, right? And second is the rolling, which is between the truck tires and the pavement, which we refer to as the rolling resistance. And the third one is the drag forces or the aerodynamics. And you can optimize this by the design of the vehicle. So here, when you have a vehicle like this, you're going to have a force on the front of the tire, and you have force in the back of the tire, and you have a friction on the surface of the tire. So if you add all this together here, you will get what is the drag force that is applied on the truck. Now imagine here, if I'm going to get these trucks behind each other, now this one here, it has much, much less force coming from the front. So that will reduce the drag forces significantly. And if I take this truck and shift it a little bit here, then in that case, this will start increasing. So you can just look at this from a conceptual point of view. The number here that you can see, the one in the lead is at 0.29, this is 0.21, so there is some significant reduction here. But if I shift it a little bit, that could be increased. So it depends where the location of this. Keep this in mind as we're going forward here to discuss the optimization of the platoons. Now, from the pavement's point of view, here's the scenario. As you are moving the platoons here, you're just going to keep going in the same location again and again and again. You're going to be increasing here the stresses or the strains, whatever you're going to look at. And at some point, you're going to have significant damage happen to the surface. So if you have platoons, that's definitely going to be accelerating that damage to the pavement. So if we look at this schematics here, this is a tire that you have channelized traffic and it just keep going in the same direction again and again, and you're going to end up with something like this. This is a true picture from the West Track in Nevada, where at that time they do have a truck, and the truck was, they have, like here maybe you can see it here in the middle, they have a guided wire, and the trucks was moving the same location all the time. So this is the kind of damage that you have. This is what you're going to be expected to see in pavements if we go with this approach. The other approach is to start now thinking about moving this to the right, to the left, and do the winder. So you can see here, if this is the shape that we have from the stresses, this is going to be better distributed here, and you're going to be having less distresses in the pavement. Now, in order to do localized optimization within the platoon, you can start shifting. So if you are shifting this, you can see here, these shifts now will give you a lower strain or lower stress, but it's in different location. Does that make sense? Okay. Now, the better approach is to go ahead and try to have now the same platoon in the same direction, but have different platoons having different locations. If we start to do this now, that will optimize this and at the same time reduce the drag forces on each platoon. That's the whole idea behind it. Okay. So if we wanted to design now for the lateral position, you can see here what's happening in the lane position. We can now have the positions, or call it the probability density function for the wheel position. If we shift it 12 to 12 inches, this is how this is going to look like. But at the same time, we don't always have this. We have also human-driven trucks. So you're going to add this to this. And I'm going through this here because I wanted to show some of the work that the group here did in order to see how we're going to be combining if it's going to be completely channelized, or it's a human-driven, or it's going to be a combination of like human-driven and a grid system where we can be optimizing the design over specific locations, or just have it completely autonomous. Another thing which is really important here is how is this distance between the trucks going to be impacting the pavement itself, especially when we are dealing with asphalt concrete. Of course, for Portland cement concrete, it's less of a problem, but there is another problem we need to think about, which I'm not discussing here, which is the erosion, because that's going to be increasing the frequency, and that's going to cause an erosion problem underneath the joints of the slabs in the concrete. But for flexible pavement, we know that this material is a viscoelastic, which means that the material will not be recovering completely when the next truck is coming, which means here that before it's recovered completely, you're going to be hit with another load, and that could be a problem. Another thing here is as you are turning around, there's going to be some significant shear, and that's also when you have a platoon, you are not having enough time for the materials to recover. So all these are concerns that needs to be addressed. And in order to do that, we did two things. I'll talk about the simulation. Our partners in Arizona, they are doing some experimental work on this. And I will not discuss the experimental work because it's still going, that's one. And the second, because there's different things that it's impacting this, that it has different results than the simulation, but I'll not get into that now. So we'll just focus on this part here. So we did finite element, and we did look into the impact of the distance on this, and see what is the rest period. The rest period is the period between this here and this tire comes behind it. So we'll see what is the distance that it can be saved for the recovery of the materials, that you can have the distance as a minimum between the two. Remember here, the closer the trucks, the better from the drag force point of view, right? The less going to be on that. But at the same time, we don't want it to be very, very close, because we need the materials to recover before you hit it again with another load. Okay. So to do that, this is how the trucks look like. Please notice here that in the truck itself, it could be a single, or it could be here you have a tandem. So what we did is we modeled the load. We have the 3D for the tire itself, and we have people have been in our group working for the past 20 years on developing modeling for the tire and the pavement itself. So we put all that to use on this application. And we added for the first time is to add the tandem axle effect. So here we wanted to see when two tires are moving at the same time, what is the impact going to be from tire 1 to tire 2? And this is going to be impacted by what is the speed of these tires. The second is to look into this impact here from the tandem and the next axle that it's going to come from the steering load. But the problem, this is going to be very, very expensive computation because it needs a lot of space. But at least we now have an idea, and the results that came up with one of the students who did the work and said, you know what, I think if we're going to be having more than 10 feet, we should be okay for the recovery of the material. I was expecting much more myself, but that's what the results show so far. So I think that issue of the rest period, I would say that it almost has been resolved in a way. So to put all this together here, we need to consider the optimization for the spacing and the lateral position of the truck. We need to see what's the impact on the pavement, and we need to look into the truck configuration and the aerodynamics or the drag forces. So this too it's kind of like you need to have a balance between them. So ultimately, we need to have an optimization, and this optimization here, with the hope that we're going to be saving some fuel for the trucking industry, while at the same time reduce the damage on the pavement, and also keeping an eye on the emission and make sure that we're reducing the energy also and the emission. So this is really great what we talked about so far, but there's another aspect to this, which is if I'm going to go to the field here, there's a few things that I need to pay attention to. First, these trucks, they are not driving on the road by themselves. There's other vehicles on the road, and we need to make sure that we are accounting the free movement or the free flow of these vehicles. So in order for the platoon to be efficient, we need this to be moving freely, right? But at the same time, you cannot have the platoon move freely and at the expense of the vehicles, okay? So for the platoons to work, we need to make sure that you have a free flow and it remains continuous. But at the same time, for the other traffic, whenever they're going to change the lane, or they want it to exit, or they want it to enter, we need to make sure that they can do that also without any problem. So here's an example where you have the trucks moving. As I said, as far as you have a free flow, everything is really nice and it's fine. But here's, imagine you have a platoon and it's moving and this car is trying to come here. So that's going to be distracted. If you have a vehicle here and they want it to exit, that's going to be distracted. So all this needs to be considered as we're moving on. So our team here, what they did, they said, we wanted to look into the state of Illinois and see where you can have a platoon and where you cannot have a platoon. So they looked into the data in the state of Illinois and considered 5 different levels. These levels here, it vary, but it depends on the volume capacity. And they said, all right, this is here. We're going to look in also into the number of the interactions within 20 miles, like an exit or an entrance. So if we look at this, we find at level 3, during peak hours, almost 89% of the interstate system in the state of Illinois is platoonable, which is really good. Off-peak hour, that number went to 93, Igman, 93, 94, something like this. I forgot the exact number, but we did a report on this that was submitted. It's just to tell the state of Illinois, you know what, these are the percentage, or these are the roads that you can have platoon on in the state of Illinois. And this is one of the things that it's going to come very soon to all the states, is we need to develop some protocols, because each state now, they have their own protocols or developing some guidelines for platoons. But if you have a truck coming from Wisconsin and Indiana, they have different protocols, they are guidelines. These things needs to be also meeting the guidelines and protocols here. So there get to be some discussions between the different states in order to establish protocols that it will not be surprising the truck drivers as they are moving from one state to another. Here's I think I will be ending with an example here. Let's assume that you have 1,000 trucks per day, and the lane width is 12 foot, and the truck width is 8 feet. And we have different platooning schemes. We did this work here for the state of Illinois. One is you have human-driven trucks. This is a channelized trucks. The other one is a mixture of human-driven and connected trucks. And the last one is fully connected trucks. This is taken for, I would say, not a very strong pavement, but it's 5 inches of hot mix asphalt, 6 inch of base layer, and the subgrade. So the human-driven, it's normally distributed. So in this case here, that's how you drive. Okay, so it's going to be normal distributed. This one here is channelized. It's going to be the zero, everything is at a specific, moving at a specific pass. Here, assuming 40% of the traffic is connected and the 60% is human driven. So that's how it looks here. We're choosing here 3 places actually. So you have 12-inch to the left, 12-inch to the right. And this one here, it's 100% connected, and we are controlling them to be moving at 12 inches, at 18, here's at 0, and here's at 12 inches, and here's at 12 inches. Now the question is, we didn't, or I did not go through this here, but we did look into having many different spaces, and we found that if we're going to go with 3 or 4 or 5, it's going to give us almost the same results. So we're going to live with 3, and that should do it. So we don't want to complicate things in real life. Am I right, Watik? Okay, that's Watik's work. So, all right. So this is the beauty here. We look at the human driven. We're looking at the cracking that we are expecting within 10 years in the pavement that I just showed you, the pavement structure, and we're looking at the rutting. So for the human driven, that's how it looks like over 10 years. It's going to be the cracking increasing, the rutting as you are expecting, it's going to be increasing at the beginning significantly, and then it's going to increase with time, keep increasing, but at much slower rate. So this is the human driven. So if we're going to go to channelize, what do you expect going to happen? It's going to be worse, right? So this is the channelized. So that's going to be worse. Okay. Now, if we have 40% connected, sorry, I should have changed this to connected instead of just. So this one here now, it's less for cracking and less for rutting. If we go for fully connected, that will be even much less for both the cracking and connected, because now this is completely optimized. This is, we'll say, partially optimized because it's optimized for the connected, but it's not optimized for the human driven. Okay. The advantage of this is find that they're going to be a reduction of almost 46% in the cost and 36% in the emission. And this is going to be significant. Of course, this is just for this particular example. So in general, or in summary here, platooning, it is coming, and I think it's being tested. And I believe it's going to be saving significant energy. And the trucking industry is very, very excited about it because, as I told you, fuel and labor are the most expensive 2 items in the trucking industry. It is supposed to enhance safety. And of course, it will reduce the demand of drivers. So let me maybe emphasize here what I was talking about platooning. I'm talking about connected. I'm not talking about taking the drivers of the truck number 2 and 3 and 4. Okay, the driver is going to be still there, but they will not be completely engaged with full attention. That's why I'm saying connected. So maybe they will be allowed to work a little more. I don't know. This is something that human factors people can address. But in general, I think that might solve part of the problem that we have with the shortage in trucking drivers. So the technology could potentially increase also the pavement life based on what I just showed you here, if we change this challenge to an opportunity and we optimize this in a way that we can connect to these trucks and make sure that we do it properly. Platoonable sections can be identifiable. So we did that for the state of Illinois. So the state of Illinois now, they can tell you which sections they can be platooning off-peak hours or during peak hours. And if anybody's interested, that's already published in a report. And the probabilistic strain can be used to predict the pavement distresses for any of the truck versus the truck, I guess, connected trucks versus human-driven trucks. So that can be done also. And optimum platooning scheme could reduce the life cycle cost as well as the environmental or the life cycle assessment or the emission that we have. So with that, I'll stop here and I will entertain any questions before I do so. I want to ask many people who contributed to this work. This work has been going for a little more than 5 years. I just gave you a little touch about what's going on. So Yamfing and his student Roofing, she was working with us on this. Erman, he graduated, and Eggman and Chinwen, as well as Aravind and Wathik, they are all have been working on this topic. So I thank them for all the contribution. So I'm sure that they were seeing here and said, gosh, the work that I did in 2 years, he summarized it in maybe 2 slides. So, but that's the whole idea. It's just to try to give you a very good idea about what's the work that these guys has been doing. It's an excellent work. So thank you, and I will take any questions that you may have. Who's coordinating this? Me? I'll take it. Neat. Okay.
This is great to see everything what we have been doing in one presentation. So I have a question regarding the pavement design aspect. So we are seeing a change of how the traffic is changing, and probably with the COVID hit, a lot of people are working from home, and that will definitely put more burden on the freight. Now there will be more freight movement because people are trying to work from home. They probably don't want to move from one place to the other, and so will probably increase the freight traffic. And so what we expect that a pavement design life, which would have been 10 years, let's say, before it undergoes any major reconstruction or rehabilitation, will probably reduce to maybe 6-7 years because of these unforeseen changes in the demand and supply when it comes to freight traffic, let's say. So how, from the pavement design perspective, are we considering that that forecast that things will change in that way, and are we ready for that or not? Like,
first, I wanted to thank you for your question. First, I wanted to answer the first part of your question. What you said is not exactly true. Because of COVID-19, that doesn't mean the trucking or the freight has increased. It's true that we're depending more on the e-commerce, but the problem is there is a major problem in the supply chain at this moment, and a lot of the stuff is not getting, I guess, per the orders that we do. And accordingly, if you look at the Trucking Association, they are saying that the freight tonnage went down in 2020, but they are expecting this to increase again in the next 4 or 5 years. And they are expecting this to be increased at 4.5% and then move to 3.5%. That's the first part. I just wanted to make sure that I'm accurate about that. It does not mean that during COVID-19 that there was more freight. It was less, actually.
just to
So,
yeah, just
but you are expecting more, of course, but
yeah,
but expecting because of the e-commerce. But as I told you, the supply chain and the logistics part was not as we were hoping, because I think if you ask Greg, he will tell you I order things and it's not been here for a while. Am I right, Greg?
Absolutely.
I mean, everything we're trying to order now, it's so that's the first part. Does that make sense?
Yeah.
Okay. Now the second part is regardless of the increase or not. I think the pavement design is a very complex. I sometimes feel bad myself that we do so many great things in our life, from even building space shuttle and all that stuff. But then when it comes to the pavement, we're still doing the same problems. And I think it's more related to the way that we construct things, the way that we are trying now to convince people to use the new technology. That's the real problem, in my opinion. I do believe that at the moment that we start like force the use of new technologies in everything, from the material testing to the design, to the construction, and the way we monitor things and we report it, things will get better. Can you design a pavement that it will, I guess, sustain for 40 and 50 years? The answer is yes. I remember one time I was in Philadelphia like a week ago for a day, and I was passing and I said, you know what, I wanted to see this old Navy Yard, but I didn't. But this is an area that it was very close up grade, and they wanted to use it for very, very heavy containers. And they put like 3-4 containers on top of each other, and that's very static load and heavy and all that stuff, the pavement. And at that time, I remember I was young. That was like maybe 20 years ago. Oh, not maybe 15. Okay, and I was young, and I used very advanced way for the design with this company, and it was much less than you are building an interstate highway system. So I'm standing in front of you. I don't think that anybody sued me, so it means it's working after 15 years, right? So what I'm trying to say is we can do things right, but they have a very, very strict quality control. I can tell you one of the tests, because you work on pavements, that I requested at that time is to run a shear test for asphalt concrete, which we don't run because that's an expensive piece of equipment. But they did. And frankly, it's still working till now, so it's good. Yep.
Thank you.
I'll go with Greg first. Yeah.
Mike, you had talked about a lot of the work being to optimize the configuration of a platoon for the characteristics of pavement as they're currently designed. Do you see a time in the future with greater implementation of autonomous and/or connected vehicles where you might optimize pavement design for your idealized platooning configuration?
Absolutely, absolutely. That. So I can go on and answer it in a long way, but I can tell you the answer is yes, because as we are moving forward, the reason why we don't have instrumentations in the pavements right now is because of the wiring and the life of the instruments and so on. So if you put an instrument right now, the average life for the instrument is maybe 4 or 5 years. And then you have the wiring and all that stuff. If we start now putting the wireless and the small sensors that it's going to be self-powered, then that will take us for a long time, and that will allow us to do the health monitoring of the pavement and try to even maintain the pavement before it reach the failure level, because that's usually where we get into trouble. Remember that pavements usually, when the failures start to appear on the surface, that's when it reaches a very advanced stage. So usually if the stresses occur at the bottom by the time that, if it occurs within the pavement, at the time that it gets to the surface, this means that the damage has already been done. So if we do that, of course, that will allow us to plan for the maintenance rehabilitation. The second part of your question is, what can we do to make sure that these same instruments can be connected with the trucks, for example, to control the platooning? That's the whole idea. So the whole idea is either you're going to be controlling the platoons from the side or from within the pavement. So I can use the same instrument in order to communicate with the control center, communicate with the other trucks to do the platoons.
One little follow-up, then in addition to like the mechanical properties of say the cross section of pavement, could you see like a geometry change where it's like, I realize the potential that it's kind of like a semi tractor trailer on rails, on a virtual rail, you know, approaching the like a train, you know, where you're going to see this. So you might thicken your section only where you know you're going to have wheels, because you can rely on that traffic stream staying channelized.
I can tell you this. He's the president of a very, very large company. I don't want to even name the country, but we were having dinner one, and his dream, his vision, and this guy, he did achieve his visions in other areas. That's all I can tell you. His vision is to have trucks driving without touching the pavement. It's the first time I'm talking about this, but that's his vision. The more I thought about this, there is nothing impossible. Okay, just think about it that way, because the back train that you have now is not touching the rail anyway. But there is some more thinking going to be going into this. For the reasons that I mentioned, which is the exit and the entrance and so on, I'm not seeing this happening actually in the near future. The reason why people are using the freight trucks more than using, for example, rail, is because of the flexibility, the ability to get into an exit and get to from. The the warehouse, like if you look like on the 90, there is, or 94, there is 94 actually. So there is many warehouses for major companies. I mean, these people, they need exit and they need to enter the interstate system. And that's what makes it really flexible. Before, if you look at the rail track, which is, I'm not an expert, but you find that many people who have farms or they have factories, they used to have it near the track for the transportation, right? For moving this. Now that's the part. The second part is, you said the geometry. I don't think that when we're gonna have the autonomous vehicle and going one direction, we need to change that for the reasons that I explained at the platooning, that we need to have this flexibility of wandering, or call it controlled wander, so we will not be having more damage to the pavement. I'm gonna take Jose and then you.
Platoon shift lanes in Platoon, or should shift
I'm sorry, you
lanes-
need to speak louder.
Should the platoons, the trucks in the platoon change lanes as a group, or should change lanes individually when there's an emergency, like stop vehicles or near to an exit?
I think that's something that it has to be done with the experts in that field, which is like, for example, if you have the good communications between all the vehicles, I'm not talking about here just the trucks. It is communications going to be in the future with the other vehicles, and they will be negotiating when the platoon can be moving to another lane without a problem. So this is all going to be part of the communication that is going to be created between all the vehicles as well as the infrastructure surrounding that. So I don't think that at this point, you know, when we started this work, to be honest with you, we were thinking at that time, and I don't know if Professor Oyang with us here, but at that time, his student was working on what is the optimized number of trucks in the platoon. I mean, we were at that time, we found that when you reach number 6, after that, there is no much more savings. So it's 6 or more, it's the same, okay? But the question is, are we now ready for 6? My answer is no. I mean, we are ready for 2 and 3, but maybe in 3 years after we have good experience and things are working well, we start moving. So at that time, we found that the optimum number, where that optimum number is. That was part of the work that he did. Yes, ma'am.
Professor, there's a online question.
Oh, do you want to read it for me, or do you want me to read it?
No, he wants to ask it himself, so.
Oh, so what shall I do?
Hi, Professor. Can you hear me?
I can if you speak a little louder.
All right. Hi, Professor. Can you hear me now?
Yes.
Yeah. Thank you so much for the presentation. It's lovely. I just have a quick question. One thing that comes to mind is, why are we not considering having multiple payloads per truck? Instead, we are considering having multiple trucks that are connected. And another question that I have is, has there been any research on, because there would be a certain time where these platoons would be interacting with semi-connected or potentially unconnected vehicles, which would be driven more or less like they are being driven right now. Has there been any research on how safe they would be, especially in case of law enforcement? That comes to mind. If a law enforcement officer wants to pull over a truck driver who's in the middle of a platoon, so those kind of challenges, has there been any research on that?
I definitely will not be answering the second question, because I think that's going to be out of my area of expertise. So I will not be attempt to answer something that I might not do a good job on it, but I can definitely answer the first question. So I apologize, but I think my guess is going to be as good as your guess at this time, because that's more on the safety issue, and we definitely need to talk to some of our safety and reinforcement people here. But I can talk about the first part, because I was involved in national committee on this, which is the size and weight of the trucks. So if you go to Australia, for example, there is some trucks that they have several trailers, and they are long and they can move and they are happy with them. Here in the United States, that's a big, big issue for us. Even just adding one, there is a lot of disagreement about it. That's one. The second is when you are moving this, our geometric design for the roads and the bridges is not ready for this. However, in the Platoon, you can separate them at any time and you can connect them at any time you want. So that's the difference between the two. Let's assume that, as I mentioned in my presentation, that you need some kind of a minimum time, a minimum distance for the platoons. We estimated that to be around 20 miles or 15 minutes in order to have a free platoon. But if you are getting to an exit and you wanted to let some cars move, you know what? You can break this platoon and you can reconnect it again. But you cannot do that if you have several trailers connecting to each other. I mean, this question has been raised before several times, especially the people who are using this, like in Australia, as I told you. But here, there's a couple of reports that I was involved in developing, and I can tell you this will not fly in the United States for several reasons, including the safety, including the geometric that we have right now, and definitely if you wanted to break for an exit and so on. Remember, most of our interstate highway, I guess, guys, maybe one of you can correct me, it's mostly every 5 miles we have exits, unless I guess we're getting closer to big cities like Chicago. You can have it maybe every quarter of a mile or even less. But usually in interstate, we try to have an exit every 5 miles. Hope that answered your question.
Yes, thank you so much. But I just have a quick follow-up. So
Not on the second one, right?
not on the second one. Yeah. No, not on the second one. Why don't we just create a dedicated corridor for freight trucks if we are going to kind of individualize them anyways, so that they don't interact with.
I can tell you, I'm for that. I've been for that for the past 20 years. Somebody asked about it this morning, and I call it the CCC, and I forgot what the CCC for, and it's the critical commerce corridor. You see, so they remember it because I have to have somebody Google it. All I know is the CCC. But the whole idea of this is to have a dedicated lane for trucks. And frankly, I'm supportive of this idea. And there is a trial right now as we speak in Indiana for small sections to try see how this will work. It has been rejected by the Congress, just to let you know. So it has been going on for 20 years. It has been proposed and rejected, proposed and rejected. I think the impact of this is going to be positive on the freight and mobility in general. Of course, you cannot apply this everywhere, but there is some interstate system that it lends itself to something like this. The advantage I see it's not the free moving of the freight in that lane, but also the safety and the saving of life. I mean, there is, in my opinion, that the trucking industry looked at it also from the financial point of view. I'm looking at it from the safety point of view. I think it's going to be tremendous. So the answer is yes, I support that, but I think there's other political reasons. So, boy, I think it took me 8 minutes more. I think Javier should warn me for that. So if I didn't answer any of the other questions, you may write me, but I'm excited to have the Kent lectures as always. And I'm thanking the people who are running the Kent lecture. And thank you again for being here, guys.